Now in this lecture we will find out the value of line segment X. In the drawing we have triangle ABC. We know that side AB equals to side AE. We also know that line segment BD equals to 3 units, line segment DE equals to 7 units, and angle BAC, this angle equals to 90 degrees, angle BAD is equal to theta, and angle EAC is also equal to theta, and we want to find out the value of line segment EC that is equal to X. Okay, so first of all we define angle DAE as alpha. Angle DAE equals to alpha according to our definition, and we will find out the relationship between, or the ratio between the area of triangle ABD and the area of triangle ADE. So the area of triangle ABD here, the squared brackets is the sign for the area. It means the area of triangle ABD will be equal to the base of the triangle, that is actually BD, and the height to the base BD must be perpendicular to the base BD. So from point A, we go perpendicular to BD, that's actually perpendicular to BC. We define the touching point between the perpendicular from point A to BC as point M. So actually this angle equals to 90 degrees and this angle equals to 90 degrees. So the height to the base BD indeed creates 90 degrees with the base BD, so the height to the base BD is equal to AM, that is perpendicular to BD, divided by 2. The base times the height divided by 2 is the area of triangle ABD, and we will divide the area of triangle ABD by the area of triangle ADE. What is the area of triangle ADE? The area of triangle ADE will be equal to the base DE, times the height to the base. The height must create 90 degrees with the base DE, and AM indeed creates 90 degrees with the base DE, therefore AM is the height to the base DE. So it is the height equals to AM divided by 2. If we have another way, so here actually two We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And we can write down that BD times AM over DE times AM here AM over AM is 1, so AM will get cancelled, and it has given us the question that BD equals to 3 units and DE equals to 7 units. So the area of triangle ABD over the area of triangle ADE equals to 3 over 7, but there is another way to calculate the area of triangle ABD. We will use AB, side AB of triangle ABD as the base. So the base is AB, and the height to the base must create 90 degrees with the base. So here, we will, from point D, we will draw perpendicular to the base, and this line segment will be equal to the base, because the height must create 90 degrees with the base. So here, the height we define the height as edge 1, and we define this point, the touching point between the height from point D to AD as point O. So this angle is equal to 90 degrees, and this angle will be also equal to 90 degrees. Okay, so in conclusion, we found out that the area of triangle ABD, if we calculate the area in another way, it will be equal to the base AB times the height to the base, that is actually edge 1, over 2. Likewise, we'll find the area of triangle ADE. The area of triangle ADE, when we will use the base, side AE will be the base, so it is the base AE times the height to the base, and again the height to the base must create 90 degrees with the base AE. So from point D we will draw perpendicular to the base AE, so this angle equals to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point of the perpendicular from point D and AE as point K. So it is the area of triangle ADE will be equal to the base AE times the height that will define as H2. Line segment DK will be equal to H2. So it is the base AE times the height H2 divided by 2. Okay, so in conclusion, we actually found out that the area of triangle ABD equals to the base AB times the height H1 over 2, while the area of triangle ADE will be equal to the base AE times the height, that is H2 over 2. So in the next step, we'll find out the value of H1 and H2, and we'll put the value of H1 and H2 inside this equation. Okay, so what is the value of edge 1. Here we have line segment OD that equals to edge 1, and if you focus on the right triangle, triangle AOD, in this right triangle, triangle AOD, we will get that sinus theta equals to edge 1 over AD. I repeat again. In the right triangle, triangle AOD, sinus theta will be equal to edge 1 over AD. We will multiply this equation by AD, and we will get that edge 1 equals to AD times sinus theta. Okay, so we found out the value of edge 1. In the same way, we will find out the value of edge 2. So here we have line segment DK equals to edge 2. So in the right triangle, triangle ADK, in the right triangle, triangle ADK, this right triangle, here in the right triangle, triangle ADK, sinus alpha will be equal to edge 2 over AD. I will repeat again. In the right triangle, triangle ADK, sinus alpha will be equal to edge 2 over AD. So here we will multiply this equation by AD, and we will get that edge 2 is equal to AD times sinus alpha. So we actually found out the values of sinus alpha and sinus, we found out the value of edge 1 and edge 2, so we can substitute edge 1 and edge 2 in equation number 1 by the values that we found for them. We'll do it now, and we will get that according to equation number 1, 3 over 7 equals to AB times edge 1, and we already found out that edge 1 equals to AD times sinus theta over AE times edge 2, and we already found out that edge 2 equals to AD times sinus alpha. Actually here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So in conclusion, we got equation number 1 that states that 3 over 7 equals to AB over AE. AB equals to AE. According to what is given as the question, AB equals to AE, therefore AB over AE will be equal to 1, so it will get cancelled. AD over AD will get cancelled. It will be equal to 1. So in conclusion, we found out that according to equation number 1, According to equation number 1, three over 7 equals to sinus theta over sinus alpha. From the drawing, we can see that angle BAC that equals to 90 degrees, it is also equals to theta plus alpha plus theta. So angle BAC that equals to 90 degrees, it also equals to theta plus alpha plus theta. So here we get that 90 degrees, according to equation number 2, 90 degrees equals to theta plus theta is 2 theta plus alpha. So here we will subtract 2 theta from this equation, equation number 2, and we get that according to equation number 2, angle alpha equals to 90 degrees minus 2 theta. Therefore, we actually can substitute alpha in equation number 1 by 90 degrees minus 2 theta. Again, we can substitute angle alpha here in equation number 1 by 90 degrees minus 2 theta. So we'll do it now, and we will get that according to equation number 1, 3 over 7 equals to sinus theta over sinus alpha, and sinus alpha equals to 90 degrees minus 2 theta. So it is sinus alpha that equals to sinus 90 degrees minus 2 theta. And we actually have the trigonometric identity that states that sinus 90 degrees minus x equals to cosine x. So according to this trigonometric identity, we will get that sinus 90 degrees minus 2 theta according to this trigonometric identity will be equal to cosine 2 theta. In conclusion, according to equation number 1, 3 over 7 equals to sinus theta over cosine 2 theta. We have here trigonometric identity for the value of cosine 2 theta. According to this trigonometric identity, cosine 2 theta will be equal to 1 minus 2 times sine square theta. So we'll substitute cosine 2 theta by 1 minus 2 sine square theta, because they are equal to each other according to this trigonometric identity. And we will get that sine, according to equation number 2, sine theta over cosine 2 theta. According to this trigonometric identity, cosine 2 theta equals to 1 minus 2 sine square theta and it equals to 3 over 7. Here we will cross multiply this equation. Is actually equation number 1. So according to equation number 1, we will get that 7 times sinus theta equals to 3 times 1 minus 2 sine square theta. Here we will open the brackets on this side of equation number 1, and we will get that 7 times sine theta equals to 3 times 1 is 3, and 3 times minus 2 times sine square theta will be equal to minus 6 times sinus square theta. Okay, so here we will add to this equation number 1, 6 times sine square theta, and we'll subtract 3, and we get that according to equation number 1, 6 times sine square theta plus 7 times sinus theta minus 3 equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, when a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x. The value of x according to a special formula for x. X is equal to minus b plus minus square root of b squared minus 4 times a times c over 2a. And in our specific quadratic equation, the variable that we are looking for is sinus theta, so x equals to sinus theta. That is the variable that we are looking for. The coefficient a equals to 6 units. The coefficient b equals to 7 units. And the coefficient c equals to minus 3. So we'll put the data inside the equation for x, and we'll find out the value of sinus theta, because in our case x equals to sinus theta. So according to the equation for x, sinus theta will be equal to minus b, and b equals to 7, so minus b is minus 7 plus minus square root of b squared. B equals to 7, so b squared is 49 minus 4 times a is 6 times c is minus 3, all divided by 2a, that is 2 times 6. Okay, So here we actually found out that sinus theta equals to minus 7 plus minus. Inside the root we have minus 6 times minus 4 times 6 is minus 24, and minus 24 times 3 is 72. So in conclusion, we found out that inside the root we have 49 plus 72, all divided by 2 times 6 is 12. Okay? So here we have sinus theta equals to minus 7 plus minus, and inside the root we have 49 plus 72 is 121 divided by 12. The square root of 121 is 11, so I write it down. We found out that sinus theta equals to minus 7 plus minus the square root of 121 is 11 divided by 12. So we have here two possible solutions for sinus theta. The first possible solution for sinus theta is that sinus theta equals to minus 7 minus 11 over 12. This is the first possible solution for sinus theta, and the second possible solution for sinus theta is that sinus theta will be equal to minus 7 plus 11 over 12. So here, so we start with the first possible solution for sinus theta. The first possible solution for sinus theta is that sinus theta equals to minus 7 minus 11 is minus 18 over 12. So sinus theta equals to minus 18 over 12. It is actually equals to minus 1.5. Found out that sinus theta equals to minus 1.5, but because of the fact that the function sinus is between minus 1 and 1, that is to say, it can receive values from minus 1 to 1 and minus 1.5 is less than minus 1. That is to say, this answer is incorrect answer because sinus theta can never receive this value of minus 1.5 because the minimum value that sinus theta can take is minus 1, and minus 1.5 is less than minus 1. Therefore, it is incorrect answer. We cancel this answer. And the only possible solution is the second solution, that sinus theta equals to minus 7 plus 11 is 4 over 12. Here we divide both the numerator and the denominator of this side of the equation by 4, and we will get that sinus theta equals to 1, 4 over 4 is 1, and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. So here what is the value of, actually we have a rule. We know that triangle ADE is an isosceles triangle. I'll write it down. Triangle ADE is an isosceles triangle. So why triangle ADE is an isosceles triangle? Because of the fact that it is given us in the question, it is actually triangle ABE. Triangle ABE is an isosceles triangle. I will repeat again. Triangle ABE is an isosceles triangle. And why triangle AB is an isosceles triangle? Because of the fact that AB equals to AE, according to what is given us in the question, and the base of the isosceles triangle ABE is BE. The base of the isosceles triangle ABE is side BE. And we actually have rule number 1. According to rule number 1, actually in the isosceles triangle ABE, we know that AM is the height to the base, AM is perpendicular to the base BE, therefore AM is defined as the height to the base BE. Again, AM is defined as the height to the base BE of the isosceles triangle ABE. And according to rule number 1, the height to the base of an isosceles triangle bisect the base. So I'll repeat again on rule number 1, according to rule number 1, the height to the base of an isosceles triangle bisect the base. So here we have, as I already mentioned, AM is the height to the base BE, and according to rule number 1, the height AM bisects the base BE. That is to say, BM equals to ME according to rule number 1. I will write it down, that according to rule number 1, we will conclude from it that BM is equal to ME. Why? Because of the fact that the height AM to the base BE in the right triangle, in the isosceles triangle ABE, bisects the base BE. What does it mean that it bisects the base BE? It means that it divides it to two equal parts, that is to say, BM equals to ME. Okay? So according to rule number 1, BM equals to ME. But what is the value of the base BE? The base BE, from the drawing, it is very easy to see that the length of the base BE of the isosceles triangle ABE will be equal to BD plus DE. Again, the base BE of the isosceles triangle ABE will be equal to BD plus DE. But it is given as the question that BD equals to 3 units and DE equals to 7 units. So in conclusion, we found out that BE equals to 3 plus 7 is 10 units. BE equals to 10 units. So the base BE of the isosceles triangle ABE equals to 10 units. And according to rule number 1, BD equals to ME. BD equals to ME. And repeat again, according to rule number 1, BD equals to ME. So if we define BD as Y, then from this equation Y equals to BD equals to ME, we will find out that ME is also equals to Y. So BD equals to Y and ME is also equals to Y. So the value of line segment BE, is equal to BM plus ME. Here actually we have here, we know that according to rule number 1, BM equals to ME. According to rule number 1, BM equals to ME. And so if we define BM as Y, then ME will be also equal to Y. So if BM equals to Y, then ME will be also equal to Y. Again, if BM equals to Y, then ME will be also equal to Y. Why? Because they are equal to each other. So what is the value of BE? BE equals to BM plus ME. BE equals to BM plus ME. But BM equals to Y, according to our definition. And ME is also equals to Y. So in conclusion, we found out that from one side, BE equals to Y plus Y is 2Y, and from the other side, we already found out that BE equals to 10, BE equals to 10. So from this equation, 10 equals to BE equals to 2Y, we will conclude that 2Y equals to 10. Here we divide this equation by 2 and we'll get that Y equals to 5 units. Y equals to 5 units. That is to say, BM that equals to ME, BM that equals to ME, and both are equal to Y according to our definition, equals to 5 units. So here we can write down that BM equals to 5 units and ME is also equal to 5 units. Okay. So in the next step, we will prove that the right triangle ABM this right triangle congruent to the right triangle AME. I repeat again, we prove that the right triangle ABM congruent to the right triangle AME. So why those two triangles congruent to each other? First of all, it is given us the question that AB equals to AE. AB equals to AE is given. So AB equals to AE, it is given us in the question, and we have already proved that BM is equal to ME, equal to 5 units. BM equals to ME equals to 5 units. And we also have a common side, AM equals to itself. It's a common side that belongs to both triangles. AM equals to AM. It's a common side that belongs to both triangles. So we actually proved the triangle ABM congruent. This is the sign of congruent to triangle AME according to side rule. Okay. all the sides of triangle ABM congruent to all the sides of triangle A and B, therefore that are congruent to each other according to side rule. And from the fact that those two triangles congruent to each other, we will conclude that angle BAM is equal to angle MAE. I'll repeat again. We conclude that angle BAM is equal to angle MAE according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding angles, that is to say angle BAE and angle MAE, will be equal to each other. So, if we define angle MAE as Z, then angle, from this equation, we will conclude that angle BAM is also equal to Z. And what is the value of angle BAE? The value of angle BAE, from the drawing, it is very easy to see that the value of angle BAE, the value of this angle equals to theta plus alpha. Okay. This is from one side, but from the other side, the value of angle BAE is also equal to angle BAM plus angle MAE. Again, from the other side, the value of angle BAE equals to angle BAM plus angle MAE. But angle BAM equals to Z according to our definition, and angle BAM equals to Z according to our definition, and angle MAE is also equals to Z. So we can write down that angle BAE equals to Z plus Z, and Z plus Z is 2Z. So in conclusion, we found out that angle BAE from one side equals to 2Z, but from the other side it equals to theta plus alpha. So from this equation, theta plus alpha equals to angle BAE equals to 2Z, we'll conclude that theta plus alpha equals to 2Z. Here we will divide this equation by 2 and we get that angle Z equals to theta plus alpha over 2. So here angle BAM that equals to angle Z, it will be equal to theta plus alpha over 2. And angle MAE that is also equals to Z, it will be also equal to theta plus alpha over 2. Okay? So in the next step we will focus on the right triangle, triangle AME. So we'll copy the right triangle, triangle MAE in a new page, and we will analyze triangle AME, the right triangle, triangle AME. So this is the right triangle, triangle AME. We will define side AM of triangle AME as H. Here AM equals to H according to our definition. So here we will get that in the right triangle, triangle AME, we will get that according to equation number 1, tangents theta plus alpha over 2 will be equal to ME over AM. ME equals to 5 units, AM equals to H. So in conclusion, we found out that according to equation number 1, tangents theta plus alpha over 2 equals to 5 over H. I'll repeat again. We found out that according to equation number 1, tangents theta plus alpha over 2 equals to 5 over H. Okay. In the next step, we will focus on the right triangle, triangle AMC. So I will copy triangle AMC in the new page and we will focus on this triangle. Okay. So we have the right triangle, triangle AMC. So what is the value of angle MAC? What is the value of this angle? It is very easy to see that the value of angle MAC, from the drawing it is very easy to see that the value of angle MAC is actually equals to theta plus alpha over 2 plus theta. Repeat again, the value of this angle MAC, equals to theta plus alpha over 2 plus theta. Okay, so here we can write down that the value of angle MAC equals to theta plus alpha over 2 plus theta, and we know that the sum of the angles in triangle, the right triangle AMC is equal to 180 degrees. That is to say, here we have 90 degrees plus angle MAC plus angle MCA. In total, the sum of those three angles in triangle AMC must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Here we will subtract 90 degrees from this equation, and we get that angle MAC plus angle MCA equals to 90 degrees. So here we will subtract the value of angle MAC from this equation, and we get that the value of angle MAC and the value of angle MCA the value of this angle MCA equals to 90 degrees minus the value of angle MAC. I'll repeat again, the value of angle MCA, this angle, is equal to 90 degrees minus the value of angle MAC, the value of this angle. So, and we have already found out that the value of angle MAC equals to theta plus alpha over 2 plus theta. So here we can write down that the value of angle MCA equals to 90 degrees minus the value of angle MAC, that is actually equals to theta plus alpha over 2 plus theta. So I'll write it down, equals to theta plus alpha over 2 plus theta. we know that angle MAB, angle BAC, this angle that equals to 90 degrees. From one side, this angle equals to 90 degrees, but from the other side, angle BAC equals to theta plus alpha plus theta. This is to say, it equals to 2 theta plus alpha. So we can substitute 90 degrees by 2 theta plus alpha, because 90 degrees equals to 2 theta plus alpha according to this drawing. So we get that so we substitute 90 degrees by 2 theta plus alpha, and we have to subtract from it theta plus alpha over 2 plus theta Here we will open the brackets here, and we get the 2 theta plus alpha minus theta plus alpha over 2. This will be inside the brackets, minus theta. So angle MCA equals to 2 theta minus theta is theta. So we found out that angle MCA equals to 2 theta minus theta is theta plus alpha, theta plus alpha minus theta plus alpha over 2. And actually here theta plus alpha minus theta plus alpha over 2 will be equal to theta plus alpha over 2. Okay? Will be equal to theta plus alpha over 2. So in conclusion, we found out that the value of angle MCA is equal to theta plus alpha over 2. So we can write here that the value of angle MCA, or I will draw it in a new page. I repeat again, we found out that the value of this angle MCA equals to theta plus alpha over 2. And according to our definition, AM equals to H. What is the value of MC? You can see it easily from the drawing that MC equals to 5 plus x. Okay? MC equals to 5 plus x. So if you read to the right triangle the angle AMC. Here we can write down that tangents theta plus alpha over 2 will be equal to AM over MC. So again, tangents theta plus alpha over 2 equals to AM over MC. But AM equals to H according to our definition, and MC equals to 5 plus X. So in conclusion, we found out that according to equation number 2, tangents theta plus alpha over 2 equals to H over 5 plus X, and we've already found out that according to equation number 1, tangents theta plus alpha over 2 equals to 5 over H. So we create equation number 3 that combines equation number 1 with equation number 2. So equation number 3 will be equal to the combination of equation number 1 with equation number 2, that is to say it will be equal to tangents theta plus alpha over 2 that equals to H over 5 plus X according to equation number 2, but it is also equals to 5 over H according to equation number 1. So actually equation number 3 is the combination of equation number 1 with equation number 2. Okay? So in the next step, we will find out the value of theta plus alpha over 2. So what is the value of theta plus alpha over 2? So actually the value of theta plus alpha over 2 will be equal to theta, and we have already found out that alpha equals to 90 degrees minus 2 theta, so we'll substitute alpha by 90 degrees minus 2 theta. Okay, divided by 2. So here we have 90 degrees. Theta minus 2 theta is minus theta over 2, and it equals to 90 degrees over 2 is 45 degrees minus theta over 2. So in conclusion, we found out that the value of theta plus alpha over 2 equals to 45 degrees minus theta over 2. Therefore, if theta plus alpha over 2 equals to 45 degrees, minus theta over 2, then it is true to say that tangents theta plus alpha over 2 will be equal to tangents 45 degrees minus theta over 2. If alpha equals to beta, then tangents alpha will be also equal to tangents beta. So it is very simple here. And we have the trigonometric identity for tangents x minus, write it in the red color. This is the trigonometric identity that states that tangents x minus y equals to tangents x minus tangents y over 1 plus tangents x times tangents y. So we use this trigonometric identity in order to find out the value of tangents 45 degrees minus theta over 2. And we get that according to this trigonometric identity, the value of tangents 45 degrees. So I'll write again the whole equation that tangents theta plus alpha over 2 equals to tangents 45 degrees minus theta over 2 So according to this trigonometric identity, tangents x minus y equals to tangents x minus tangents y over 1 plus tangents x times tangents y. We will get that tangents 45 degrees minus theta over 2 will be equal to tangents 45 degrees minus tangents theta over 2 over 1 plus tangents 45 degrees times tangents theta over 2. As we already know, tangents 45 degrees equals to 1, so we get that it is equal to 1 minus tangents theta over 2 over 1 plus tangents 45 degrees is 1, so it is 1 plus tangents theta over 2. So here we have the expression of tangents theta over 2, but we also have trigonometric identity for tangents theta over 2. According to the following trigonometric identity, the value of tangents theta over 2 tangents theta over 2 equals to sinus theta over 1 plus cosine theta. Okay? We have already found out that sinus theta equals to first 1 over 3 And we have another trigonometric identity that states that sinus squared theta plus cosine squared theta equals to 1. We'll subtract sinus squared theta from this trigonometric identity, and we'll get that cosine squared theta equals to 1 minus sinus squared theta. Here we'll take a root out of this equation, and we get that the value of cosine theta, according to this trigonometric identity, is equal to the square root of 1 minus sine square theta. So actually, cosine theta equals to the square root of 1 minus, we know that sinus theta equals to 1 over 3, therefore if sinus theta equals to 1 over 3, then the sinus square theta will be equal to 1 over 9. And here 1 minus 1 over 9 equals to 8 over 9, so inside the root we will have 8 over 9, and 8 equals to 4 times 2. The square root of 4 is 2, so in conclusion the square root of 8 is 2 times square root of 2, and the square root of 9 is 3. So in conclusion, we found out that cosine theta equals to 2 times square root of 2 over 3, and sinus theta equals to 1 over 3. So now we can put the values of sinus theta and cosine theta inside this trigonometric identity in order to find out the value of tangent theta over 2. I will write down the trigonometric identity again. The trigonometric identity states that tangent theta over 2 equals to sinus theta over 1 plus cosine theta. So here we know that sinus theta equals to 1 over 3, so it is 1 over 3 plus 1 plus cosine theta, that equals to 2 times square root of 2 over 3. Here we will multiply 1 by 3 and then we will divide it by 3 in order to have a common factor with this expression, and we get that equals to 1 over 3 plus 3 plus 2 times square root of 2 over 3. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. So in conclusion, we found out that tangent theta over 2 is equal to 1 over 3 plus 2 times square root of 2. So here we take the expression of 1 over 3 plus 2 times square root of 2, and we will multiply it by 3 minus 2 times square root of 2, and then we will divide it by 3 minus 2 times square root of 2. It is allowable to divide, to multiply and divide anything by 1, and this expression equals to 1. So we multiply this expression by 1, and we get that 3 minus 2 times square root of 2. This is the expression in the numerator, and in the denominator we have 3 plus 2 times square root of 2 times 3 minus 2 times of 2 is according to the trigonometric, to the algebraic identity that a plus b times a minus b equals to a squared minus b squared. So here a is 3, so a squared is 3 squared is 9, minus b squared. B is 2 times square root of 2, so b squared is 2 times square root of 2 squared, and 2 times square root of 2 squared is 8. So in conclusion, we found out that it equals to 3 minus 2 times square root of 2, and anything divided by 1 doesn't change its value, so actually this expression equals to 3 minus 2 times square root of 2. So in conclusion, we can write down that the value of tangent theta over 2, according to what we have already found out, it equals to 3 minus 2 times square root of 2. After we found out the value of tangent theta over 2, we can put the value of tangent theta over 2 inside the equation that states that tangents theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So we substitute tangent theta inside this equation by 3 minus 2 times square root of 2, and we get that the value of tangent theta plus alpha over 2 is equal to 1 minus, and the value of tangent theta over 2, according to what we have already found out, is equal to 3 minus 2 times square root of 2 divided by 1 plus tangent theta over 2, that is equal to 3 minus times 2 times square root of 2. So here 1 minus 3 is minus 2, and we have minus before the bracket, so this sign will be changed from minus to plus, so it will be plus 2 times square root of 2 divided by 1 plus 3 is 4 minus 2 times square root of 2. So here we actually found out that according to this equation, tangent theta plus alpha over 2 is equals to 2 times square root of 2 minus 2 over 4 minus 2 times square root of 2. So here we will take 2 as a common factor from the denominator, from the numerator, and inside the brackets we'll have square root of 2 minus 1, and from the denominator we will take a common factor of 2 times square root of 2. Inside the root, what is remained is square root of 2, because of the fact that square root of 2 times square root of 2 times 2 is 4. And here, what is left is minus 1. So here, square root of 2 over square root of 2 is 1, so it will get cancelled. 2 over 2 is 1, so it will get cancelled. So we left with we left only with 1 over square root of 2. So in conclusion, we found out that tangents theta plus alpha over 2 is equal to 1 over 2. Now we will return to equation number 3. According to equation number 3, we have already found out that tangents theta plus alpha over 2 is equal to h over 5 plus x, that equals to 5 over h. Okay, this is actually equation number 3 that I copied, and we just right now found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. So here, from this equation, we have this equation that 5 over h is equal to 1 over square root of 2. Here we will cross multiply this equation, and we get that 5 times square root of 2 equals to h. So we found out that h equals to 5 times square root of 2, and we will create another equation that states that h over 5 plus x equals to 1 over square root of 2. Okay, according to the following equation, h over 5 over x, h over 5 plus x equals to 1 over square root of 2. But we've already found out that here that h equals to 5 times square root of 2. So we can substitute h in this equation by 5 times square root of 2. We'll do it now, then we get that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2. Here we will cross multiply this equation, and we will get that 5 times square root of 2 times square root of 2 equals to 5 plus x. So here square root of 2 times square root of 2 is 2, and 2 times 5 is 10, so we have here in this side of the equation 10 equals to 5 plus x. Here we subtract 5 from this equation, and we will get that x equals to 5 units. So we found out that the value of line segment X that equals to CE is equal to 5 units. Okay, so I'll repeat again. The value of this line segment EC that it is equal to X is equal to 5 units. EC equals to X equals to 5 units. That is the answer to the question. So in the next step I will summarize the lecture. Okay, so we have here the triangle ABC. We know that angle BAC equals to 90 degrees, angle BAD equals to theta, angle EAC is also equal to theta. We also know that AB equals to AE. We know that line segment BD equals to 3 units and line segment DE equals to 7 units, and we want to find out the value of line segment EC that is equal to X. Okay, so first of all, from point A, we draw perpendicular to BC, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees. We define the touching point of the perpendicular from point A to BC as M, and then we calculated the value, the ratio between the area of triangle BAD over the area of triangle ADE. The ratio between the area of triangle ABD, the square brackets is the sign for the area, it means the area of triangle ABD over the area of triangle ADE. What is the area of triangle ABD? The area of this triangle ABD equals to the base of the triangle, that is BD, times the height to the base, that is AM. Why AM is the height? Because it creates 90 degrees with the base BD. So it is BD times the height AM over 2. So the area of triangle ABD equals to the base BD times the height to the base, that is AM, over 2. And what is the area of triangle ADE? The area of triangle ADE equals to the base of the triangle, that is DE, times the height to the base, that is AM. Again, the height AM creates 90 degrees with the base DE, therefore the height is indeed AM. Okay, it is the base DE times the height to the base, that is AM, over 2. But we have, so here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And from this expression we'll get that BD times AM equals to BE times AM. Here AM over AM is 1, so it will get cancelled, and we left only with BD over BE. According to what is given us in the question, BD equals to 3 units and DE equals to 7 units. So here we can write down that BD equals to 3 units and BE equals to 7 units. Then we calculated the areas of triangle ABD and triangle AD and triangle ADE in a different way. Actually, we can say that the area of triangle ABD equals to the base, that is AB, times the height to the base, that is actually DO. Why DO is the height to the base? Because of the fact that it creates 90 degrees with the base here. Okay, so it is the base AB times the height, that is H1, over 2. So in conclusion, the area of triangle ABD, when we calculated it in a different way, it equals to the base AB times the height to the base, that is H1, over 2. In the same way, we calculated in a different way the area of triangle ADE. The area of triangle ADE, when AD is the base of the triangle, then the area of triangle ADE Now triangle DAE is equal to the base, that is AE, and the eye to the base must create 90 degrees with the base. Here you can see that AK is indeed creates 90 degrees with the base AE, so the base is AE, the eye to the base that creates 90 degrees with the base is DK, that is H2 over 2. So in conclusion, we found out that the area of triangle AED equals to AE, that is the base, times the eye, that is H2 over 2. Here 2 over 2 will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And in conclusion, we found out that 3 over 7, but before that, we have actually calculated the values of H1 and H2. What is the value of H1? Here we have H1. We focus on the right triangle ADO. In the right triangle ADO, we know that sinus theta equals to H1 over AD. Again, in the right triangle ADO, sinus theta equals to H1 over AD. We multiply this equation by AD and we got that H1 equals to AD times sinus theta. So we can substitute H1 here by AD times sinus theta. Then we found out the value of H2 in the right triangle AKD. This is H2. So in the right triangle AKD, actually we defined angle DAE as alpha. Therefore, in the right triangle DAK, sinus alpha equals to H2 over AD. In the right triangle ADK, sinus alpha equals to H2 over AD. We multiplied this equation by AD, and we found out that H2 equals to AD times sinus alpha. So we can substitute H2 by AD sinus alpha, and we substituted H1 by AD sinus theta. And we got the equation number 1 that states that 3 over 7 equals to AB times AD sinus theta, that is H1, over AE times AD sinus alpha, that is H2. So here AB equals to AE, it is given as the equation, so AB over AE is 1, it will get cancelled. AD over AD is also 1, it will get cancelled. And we left only on this side of equation number 1 with sinus theta over sinus alpha, that equals to 3 over 7. Okay, so according to equation number 1, 3 over 7 equals to sinus theta over sinus alpha. And we know that angle BAC, the big angle BAC, from one side it equals to 90 degrees. It is given us in the question that angle BAC equals to from one side to 90 degrees. But from the other side it is also equals to theta plus alpha plus theta. That is to say it equals to 2 theta plus alpha. So angle BAC from one side equals to 90 degrees and from the other side equals to theta plus alpha. So in conclusion, from this equation number 2, we will conclude that 90 degrees equals to 2 theta plus alpha. We'll subtract from equation number 2 this equation 2 theta, and we will get that alpha equals to 90 degrees minus 2 theta. Okay, we subtracted 2 theta from this equation and we found out that alpha equals to 90 degrees minus 2 theta. After we found out the value of alpha, in equation number 2, we can put the value of alpha inside equation number 1. Okay, we did it and we got that 3 over 7 equals to sinus theta over sinus alpha, but alpha equals to 90 degrees minus 2 theta according to equation number 2. So we substituted alpha by 90 degrees minus 2 theta. And we have the trigonometric identity that states that sinus 90 degrees minus x equals to cosine x. So according to this trigonometric identity, we'll get that 3 over 7 equals to sinus theta over sinus 90 degrees minus 2 theta, but according to this trigonometric identity, sinus 90 degrees minus 2 theta will be equal to cosine 2 theta. So we can substitute sinus 90 degrees minus 2 theta by cosine 2 theta. We did it and we got this equation that 3 over 7 equals to sinus theta over cosine 2 theta. And then we have another trigonometric identity that states that cosine 2 theta equals to 1 minus 2 sine square theta. So we can substitute cosine 2 theta by 1 minus 2 sine square theta according to this trigonometric identity. We did it and we got that 3 over 7 equals to sine theta over, and cosine 2 theta equals to 1 minus 2 sine square theta according to this trigonometric identity. Here we multiply this equation number 1, and we got that 7 times sine theta equals to 3 times 1 minus 2 times sine square theta. We open the brackets in this side of equation number 1, and we got that 7 times sine theta equals to 3, and 3 times minus 2 is minus 6, so it is minus 6 sinus square theta. Here we added to this equation 6 times sinus square theta, and we subtracted 3, and we got that quadratic equation that states that sinus square theta plus 7 times sine theta minus 3 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. When a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to this special formula for x, that x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the variable that we are looking for is sinus theta, so x equals to sinus theta, a equals to 6, b equals to 7, and c equals to minus 3. So we put the data inside the equation for x, and we found out the value of sinus theta because x equals to sinus theta. So x that equals to sinus theta equals to minus b equals to 7, so minus b is minus 7, plus minus square root of b squared. B is 7, so b squared is 7 squared, 7 squared is 49, minus 4 times ac, minus 4 times a is 6, so it is minus 4 times 6, times c that is minus 3, so it is minus 4 times 6 minus 3, over 2 times a, and a is 6, so it is 2 times 6. And here, 4 times, minus 4 times 6 is minus 24, minus 24 times minus 3 is 72. So here we have 72. So found out that sinus theta equals to minus 7 plus minus 49 plus 72 over 12, because 2 times 6 is 12. 49 plus 72 is 121 over 12. So here we will have two solutions that are possible for sinus. The square root of 121 is 11, so we'll have two solutions that are possible for sinus theta. The first solution is sinus theta equals to minus 7 minus 11 over 12, and the second solution for sinus theta will be equal to minus 7 plus 11 over 12. Here we'll focus on the first solution for sinus theta. The first solution for sinus theta is that sinus theta equals to minus 7 minus 11 is minus 18, so it is minus 18 over 12, minus 18 over 12 is minus 1.5, so we found out that sinus theta equals to minus 1.5. But because of the fact that the function sinus receives values between minus 1 to plus 1 and minus 1.5 is less than minus 1, therefore sinus theta can never receive the value of minus 1.5 that is less than minus 1. Therefore this solution is incorrect solution. We'll cancel this solution and we'll focus on the solution that sinus theta equals to minus 7 plus 11 over 12. 11 minus 7 is 4, so it is 4 times 12. We divided both the numerator and the denominator by 4. 4 over 4 is 1 and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Okay? Then, because of the fact that it has given us the question that AB equals to AE, we conclude that triangle ABE is an isosceles triangle. Why? Because it has two sides that are equal to each other. Triangle ABC is an isosceles triangle because of the fact that AB equals to AE. And we have, in this isosceles triangle, triangle ABE, the base is BE. And we have rule number 1 that states that the height to the base of an isosceles triangle bisect the base. So here the height AM is the height to the base. Why AM is the height to the base BE? Because of the fact that it is perpendicular to the base. So according to rule number 1, the height AM bisects the base BE. That is to say, divide it to two equal parts, that is to say BM must be equal to ME according to rule number 1. Again, BM equals to ME equals to BM equals to ME according to rule number 1. And we have a question, BE, what is the value of BE? BE equals to BM plus ME. And but before that, here BE is also equals to BD plus DE, and BD equals to 3 units and D equals to 7 units. So in conclusion, BE equals to 3 plus 7, that is 10 units. So from one side we found out that BE equals to 10 units. But from the other side, according to rule number 1, BM equals to ME. BM equals to ME. So if we define BM as Y, then ME will be also equal to Y. From this equation, we can write, we can see it. So BM equals to Y and ME is also equal to Y, according to our definition. So BE that equals to BM plus ME, again BE that equals to BM plus ME will be equal to Y plus Y. That is to say, BE from one side equals to Y. From the other side, we have already found out that B equals to 10 units. So from this equation, 10 equals to B equals to 2Y, we will conclude that 2Y equals to 10. We divided this equation by 2. So Y equals to 10 over 2, that is 5. So we found out that Y equals to 5. That is to say, BM equals to 5 units. Here, M equals to 5 units. And BM equals also to 5 units. Then we proved the triangle ABM perpendicular triangle ABM can go into triangle AME. Those two triangles can go into each other. Why? First of all, we know that AB equals to AE according to what is given us in the question. We know that BM equals to ME equals to 5 units. That's what we have already found out according to rule number 1. And we know that AM equals to itself. It is a common side, it belongs to both triangles. So we actually found out that triangle ABM can go into triangle AME according to side rule. And from the fact that those two triangles can go into each other, we conclude that angle BAM equals to angle MAE. Angle BAM equals to angle MAE. According to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding angles, that is to say, angle BAM and angle MAE will be equal to each other. So angle BAM equals to angle MAE equals to. So they are equal to each other, and if we define one angle as Z, then the other angle will be also equal to Z. So from one side, the value of angle BAE, you can see it from the drawing, equals to theta plus alpha. Okay? But from the other side, we have already found out that angle BAE is equals to angle BAM plus angle MAE equals to Z plus Z. So here, from the other side, we found out that angle BAE equals to 2Z. Okay? So from one side, it equals to theta plus alpha, but from the other side, it equals to 2Z. From this equation, we conclude that theta plus alpha equals to 2Z. We divide this equation by 2 and we get that angle Z equals to theta plus alpha over 2. Okay? Angle Z. So, angle angle Z equals to theta plus alpha over 2, so angle MAE equals to theta plus alpha over 2, that is angle Z, and angle BAM it is also equals to theta plus alpha over 2. Then we focus on the right triangle MAE. We defined AM as edge. We have already found out that ME equals to 5. And we just right now found out that angle MAE equals to theta plus alpha over 2. So here in the right triangle MAE, we can write down the tangents theta plus alpha over 2 equals to ME over AM. And ME equals to 5 units. AM equals to edge. So in conclusion, we found out actually that tangents theta plus alpha over 2 equals to 5 over edge. Tangents theta plus alpha over 2 equals to 5 over edge. Then we focused on the right triangle AMC and copied it here. What is the value of angle MAC? You can see it easily from the drawing that the value of angle MAC it is actually equals to theta plus alpha over 2 plus theta. Okay, angle MAC equals to theta plus alpha over 2 plus theta. And what is the value of angle ACM? According to the rule that the sum of the angles in any triangle is equal to 180 degrees, so the sum of the angles in triangle ACM equals to 180 degrees, that is to say 90 degrees plus angle MCA plus angle MAC. In total, the sum of those two angles must be equal to 180 degrees. We subtracted 90 degrees from this equation and we got that angle MAC plus angle MCA must be equal to 90 degrees. Then we subtracted angle MAC from this equation and we found out that angle MCA, the angle that we are looking for is angle MCA is equal to 90 degrees minus angle MAC. Okay, so angle MCA equals to 90 degrees minus angle MAC. And we already found out that angle MAC equals to theta plus alpha over 2 plus theta. Okay, here angle MAC equals to theta plus alpha over 2 plus theta. And we know that 90 degrees equals to 2 theta plus alpha. We can see it from the drawing that 90 degrees equals to 2 theta plus alpha. So we can substitute 90 degrees by 2 theta plus alpha. We did it and we got that it equals to this expression. Here we open the brackets and we got this expression equals to 2 theta plus alpha minus theta plus alpha over 2 minus theta. 2 theta minus theta is theta. So in conclusion, we have theta plus alpha minus theta plus alpha over 2, and theta plus alpha minus theta plus alpha over 2 is theta plus alpha over 2. So in conclusion, we found out that this angle MCA equals to theta plus alpha over 2. Angle MCA equals to theta plus alpha over 2. So here, tangent theta plus alpha over 2 will be equal to AM over MC. Tangent theta plus alpha over 2 equals to AM over MC. But AM equals to H according to our definition. And what is the value of MC? You can see it for that MC is equal to 5 plus X. Okay, MC equals to 5 plus X. So in conclusion, we found out that tangent theta plus alpha equals to H over 5 plus X. So according to equation number 2, tangent theta plus alpha over 2 equals to H plus 5 over X. And according to equation number 1, we have already found out that tangent theta plus alpha over 2 equals to 5 over H. So we combined equation number 1 with equation number 2, and in this way we created equation number 3, that is the combination of equation number 1 with equation number 2, and according to equation number 3, tangent theta plus alpha over 2 equals to H over 5 plus X, that equals to H over 5. Okay, then we have, so what is the value of theta plus alpha over 2? The value of theta plus alpha over 2 is equal to theta, and alpha equals to 90 degrees minus theta, so we substitute alpha by 90 degrees minus theta over 2. So theta minus 2 theta is minus theta. So here in the numerator we have 90 degrees minus theta over 2. 90 over 2 is 45 minus 2 minus theta over 2. So in conclusion, we found out that theta plus alpha over 2 equals to 45 degrees minus theta over 2. So if theta plus alpha over 2 equals to 45 degrees minus theta over 2, then tangent theta plus alpha over 2 will be equal to tangent 45 degrees minus theta over 2, because if alpha equals to beta, then tangent alpha will be equal to tangent beta. Very simple. Then we use the trigonometric identity that states that tangent x minus y equals to tangent x minus tangent y over 1 plus tangent x times tangent y. We use this trigonometric identity in order to find out the value of tangent 45 degrees minus theta over 2. And the value of tangent 45 degrees minus theta over 2 according to this trigonometric identity will be equal to tangent 45 degrees minus tangent theta over 2 over 1 plus tangent 45 degrees times tangent theta over 2. Tangent 45 degrees is equal to 1, so it is 1 minus tangent theta over 2 plus 1 plus tangent 45 degrees is 1 times tangent theta over 2. Okay? Then we have the trigonometric identity that states that tangent theta over 2 equals to sinus theta over 1 plus cosine theta. We have already found out that sinus theta equals to 1 over 3, and we have also the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. We subtracted sinus square theta from this equation, and we got that cosine square theta equals to 1 minus sine square theta. We took a root out of this equation and found out that cosine theta equals to the square root of 1 minus sine theta sine square theta. If sine theta equals to 1 over 3, then sine square theta will be equal to 1 over 9. So we can put inside this equation the value of sine square theta that is 1 over 9. We did it, and we got that cosine theta equals to 1 minus 1 over 9. 1 minus 1 over 9 equals to 8 over 9. So in conclusion, we got that cosine theta equals to the square root of 8 over 9. The square root of 8 is 2 times square root of 2, and the square root of 9 is 3. So in conclusion, we found out that cosine theta equals to 2 times square root of 2 over 3, and sine theta equals to 1 over 3. So here we have tangent 2 theta according to the trigonometric identity Sinus theta over 2 equals to sinus theta over 1 plus cosine theta. So and sine theta equals to 1 over 3 and cosine theta equals to 2 times square root of 2 over 3. So we got this expression, and we have 1 over 3, and we multiplied 1 by 3 and then we divide it by 3 in order to have a common factor with this expression. So it is 1 times 3 is 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. And in conclusion, we found out that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 2. Here we took this expression and we multiply it by 3 minus 2 times square root of 2, and then we divide it by 3 minus 2 times square root of 2. And according to the trigonometric identity, a plus b plus a minus b equals to a square minus b square, we get that in the denominator we have 9 minus 8, and the numerator didn't change. So in the denominator we have 1, and in conclusion found out that the value of this expression equals to 3 minus 2 times square root of 2. And so in conclusion we found out that tangent theta over 2 equals to 3 minus 2 times square root of 2. And we have the trigonometric identity that states, not trigonometric identity, but we have already found out that tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So we can substitute tangent theta over 2 by 3 minus 2 times square root of 2 because it equals to tangent theta over 2. We did it, and we got that tangent theta over 2 equals to 1 minus 3 minus 2 times square root of 2, that is equal to tangent theta over 1 plus the value of tangent theta. Okay? So here 1 minus 3 is minus 2, minus and minus is plus, so it is plus 2 times square root of 2. In the denominator we have 1 plus 3 is 4, minus 2 times square root of 2. So tangent theta plus alpha over 2 equals to 2 times square root of 2 minus 2 over 4 times minus 2 times square root of 2. Here we took from the numerator 2 as a common factor, and we got that 2 times square root of 2 minus 2 equals to 2 times square root of 2 minus 1. And from the denominator we took a common factor of 2 times square root of 2, and inside the brackets we'll have square root of 2 minus 1. Square root of 2 minus 1 over square root of 2 minus 1 is 1. So it will get cancelled, and 2 over 2 is 1. It will also get cancelled, and in conclusion we found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. So according to equation number 3, tangent theta plus alpha over 2 equals to h over 5 plus x, that equals to h over 5. So, and we just right now found out that tangent theta plus alpha over 2 equals to 1 over square root of 2, so we can write it that it equals to 1 over square root of 2. So we can, from this equation number 3, we can derive that 5 over h equals to 1 over square root of 2, because multiply this equation, and we found out that h equals to 5 times square root of 2. And then we derive the second equation from equation number 3, that h over 5 plus x equals to 1 over square root of 2. And we already found out that h equals to 5 times square root of 2, so we can put the value of x inside. We can put the value of h that equals to 5 times square root of 2 inside h. Here we did it, and we got that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2, because multiply this equation, and we found out that 5 times square root of 2 times square root of 2 equals to 5 plus x. Square root of 2 times square root of 2 is 2, and 2 times 5 is 10. So in conclusion, we got that 10 equals to 5 plus x. We subtracted 5 from this equation, and we got that the value of x that equals to CE is 5 units. I'll repeat again. The value of line segment EC that equals to X is 5 units. Okay, that is the answer to the question. Okay, thank you very much.